In the last class, we started with structures, and we have seen what is a structure, why structure is used, and how to initialize structures. And also we have seen what are the various types of structures. One is a tagless structure without any tag, and then you have tagged structure, and finally we have seen the type defined structure. I think we also seen how to initialize structures. I slightly go back and I'll explain. Now if you observe, this is a structure without any tag. Now here I am having one variable by name CSC. Now if you define a structure something like this, remember memory will not be allocated. If I define a structure something like this, memory will not be allocated. But if you have a variable CSC, and then memory will be allocated. Now here you have the variable CSC, now memory will be allocated. For what are the various fields we have? Name. Name takes how many bytes? 10 bytes. What is the next field we have? The next field what we have is marks. For marks we reserve how many bytes of memory? 2 bytes of memory. And then you have one more field by name average here. Average is of type float. So how many bytes will be reserved? 4 bytes will be reserved. So all these memory locations will be given the common name. What is the name given here? CSC. Next, now if I write here CSC is equal to, then we have RAM 25 and 24.5. Then what will happen? The RAM will be copied into this memory location, and the string always ends with what? The null character. And then we have 25 here. The 25 will be copied into the marks field, and finally we have 24.5 here, that will be copied into average field. So now this is how we can initialize only one variable. Now instead of using one variable, here in the declaration let me use two variables by name a comma b here. Now what will happen here? Memory will be allocated for two variables. First, the memory will be allocated for the variable a. The entire block is identified by the name a. Next, we have one more variable called what here? B. For this B, another set of memory locations will be allocated. Name, marks, as well as what? Average. For average, how many bytes will be allocated? 4 bytes will be allocated. So the entire block now is identified. The entire block is identified by the name B here. Now if you observe, we have a comma b here. The variable a is not initialized, but only the variable b is initialized. So here what will happen? RAM will be copied into name field with respect to which variable? B here, and this 25 will be copied into b dot marks. And then you have 24.5, that will be copied into b dot average marks. So this is how, even though we have two variables here, we have initialized only one variable. Now the question is how to initialize both the variables. Now for that we use the following syntax. I write a is equal to RAM comma 25 comma 24.5 comma b is equal to SAM 24 comma 23.5. Now here how many variables are there? Two variables are there. Both variables have been initialized. Now here memory will be allocated for block A. This is the memory which has been allocated for the block A, and the name given for this block is what here? A. Next, another set of memory locations will be allocated, and here what will happen here? RAM will be copied. If you observe, RAM will be copied into the name field. Then what we have here? 25. 25 will be copied into marks field, and then you have 24.5 will be copied here. Now similarly for B also the memory will be allocated, and here name, marks, as well as what? Average. Now the entire set of memory locations, the name given is what? B here. Next, if you observe here, the name Sam will be copied into name field, and the string always ends with what? Null character here. Next we have 24, which is marks, that will be copied into marks field here. And next we have 23.5. The 23.5 will be copied into these memory locations. Now we know how to initialize two structure variables, but remember here we have no tag, so it is a tagless structure. Now what I do here, let me use the tag name. The moment I use the tag name, this becomes the tagged structure here. But remember, this is only the definition of a tagged structure. Memory will not be allocated. Now tell me, when memory is allocated for this structure, provided the entire structure now is associated with one variable. So how you declare a variable? So what we do here, I write A should be of type struct student. Now because we have the variable A, memory will be allocated. Now here we have two initial values, one is RAM 25 and 24.5. All the initial values must be enclosed within braces like this, and it should end with a semicolon. Now the moment you have the initialization or declaration with initialization like this, memory will be allocated. For which field? Name field. For name 10 bytes, and then for marks how many bytes? 2 bytes. And then average is of type what? Float. So average takes how many bytes? 4 bytes. Now the entire block is identified by the name. What is the name given here? The name given here is A. So the entire block is identified by the variable A here. Now what will happen here? The string RAM will be copied into this memory location, and the string always ends with what? Null character. Then coming back, what is the next one we have here? 25. The 25 will be copied to the next field. So here we get 0025. And finally you have the average marks, that is 24.5, and that will be copied into this particular field. So this is how we can initialize one variable using a tagged structure. Now if you want another variable, suppose I write B. Here I write B is equal to Sam, then we have 24, 23.5. Now what will happen? Again, for name, how many bytes of memory locations will be reserved? 10 bytes. And then we have, what is the next field we have here? If you observe, the next field is what here? Average. So for average, we require how many bytes of memory? 2 bytes of memory. And then what is the last field we have? Average. For average is of type what? Float. So for float means it takes how many bytes? 4 bytes of memory. The entire, all these memory locations can be grouped into a single block like this, and the name given for this block is what here? B. So for the variable B, a set of memory locations will be allocated like this. Now what will happen? The string Sam will be copied into this memory location, and the string ends with what here? Null character. What is the next data we have here? 24. The 24 will be copied into the marks field, and then you have 23.5, which represent average marks of the student B, and the 23.5 will be copied into these memory locations. So this is how we can initialize more than one variable using a tagged structure. Next, now let us concentrate on the type defined structure. So here struct can be followed by the tag, or it may not be followed by the tag. But before struct, what we require? One keyword by name type def. So here the moment we have type defined structure, here immediately after the closing brace you have to write an identifier. That identifier represent the data type. So student is the data type. Now suppose I write student A equal to RAM 25, 24.5. These three initial values must be enclosed within braces and should end with what? Semicolon. Now as usual, for name, how many bytes? 10 bytes will be reserved. And then what is the next one we have? Marks. Marks is of type what? Integer. So for marks, if I say size of integer is 2 bytes, 2 bytes of memory will be allocated. Then you have average. It is of type what? Float. So for average, 4 bytes of memory will be reserved. So all these memory locations are identified by a common name. This is a common. So what is the name given here? A. Now what will happen here? The string RAM will be copied into this memory location. It ends with what? Null character. Then we have 25, and the 25 will be copied into these memory locations. and you have 24.5, and that will be copied into these memory locations. So, this is how we can initialize the type defined structure also. Now, if you want another variable, you should have B is of type what? Student. Next, if I write B is equal to Sam 24, 23.5, enclose all these initial values within the braces like this. Now, memory will be allocated for name with 10 bytes, and then we have for marks how many bytes? 2 bytes. Then what is the next field we have? Next field is average. For average, how many bytes? 4 bytes of memory will be allocated. Now, if you observe, all these memory locations identified by name, marks and average will be given a common name. What is the common name given here? B. So, here I write B. Now, what will happen here? The string Sam will be copied into these memory locations, and the string must end with what? Null character. Automatically /0 is appended at the end. Next, we have 24. The 24 will come here, and that will be copied into marks field. And next we have 23.5, and that will be copied into which field now? Average field. So, this is how more than one variable also can be initialized using type defined structure. This is the type defined structure. I hope you understood. Okay, now let me concentrate on another example. Suppose I write something like this. Now, let us see what will happen here. How many fields are there within the structure? 3 fields are there within the structure, but here I have initialized only one value, that is the first value. Now, let us see what will happen. As usual, memory will be allocated for the name, and then marks how many bytes? 2 bytes. Then for average, how many bytes? 4 bytes. The entire block is identified by the name A here. So, this block is identified by the name A. Now, see what is happening here. Only one initial value is there, and that too the first member. This is the value for the first member. So, what will happen here? This string RAM will be copied into the memory location, that is A dot name. But remember, because it is a string, the string always ends with what? Null character. So, null character is appended at the end. Next, now we do not have any initial values for the marks as well as average. So, if nothing is there, and then automatically these 2 fields will be initialized to zeros. Now, I hope you understood how to partially initialize the structure members. Now, if you look at another one, suppose I write student B is equal to Sam 24, 23.5 and another 23.5 and end with semicolon. Now, if you observe how many initial values are there? 4 initial values are there, and here how many members are there? Only 3 members are there. So, 4 initial values, and here only 3 members. It is not possible. So, definitely the compiler will give an error. So, it is an error. The number of initial values must be equal to the number of data members, or it may be less, but it cannot be more than the number of members. Now, so what we have here? The number of initial values should not exceed the number of members. Now, suppose I have another variable C. Now, here if you observe the first one, what is the initial value here? RAM is the first value. Now, I write something like this. I write 24, 23.5 and end with semicolon. Now, even though it is syntactically correct, but remember this 24 I want to store it in which field? Marks field, and this 23.5 should be copied into which field? Average field. But remember, we have not initialized the previous members. So, unless we initialize the previous members, we should not initialize the subsequent members. Okay? So, here it is an error. Even though it is syntactically correct, it is wrong. So, that is the reason I say here it is error. We are trying to initialize the members, okay, without initializing the previous member. So, this is not possible. That is what I am saying here. So, there is no way to initialize members in the middle of a structure without initializing the previous members. We have not initialized which member? We have not initialized the name member. So, we cannot have 24, 23.5 here. I hope we understood. Now, another normal mistake what the students will do is they try to initialize the structure in the structure definites itself like this. It is not possible. You cannot initialize here. So, this is an error. It is not possible because first of all you do not have a variable A. Whenever a variable is there, then only memory will be allocated. Memory is not allocated, still you are trying to initialize. So, it is not possible to initialize the members without declaring a structure variable. Okay. Now, let us see how the data is accessed and manipulated. Now, we know that the data stored in memory can be accessed using variable names, and manipulated using expressions and operators. On similar lines, the data stored in memory can be accessed using structure variable names and manipulated using expressions and operators. How we used to access or manipulate the variables, in the same manner we can access the structure variables also. Now, look at this structure here. What type of structure it is? It is type defined structure because of the keyword type def. Now, if I declare a variable A and initialize that to RAM 25 24.5 end with the semicolon, okay, memory will be allocated like this. The entire block is identified by the name A. Now, what will happen? This RAM will be copied here, it will be terminated with null character. Then here what you will get? 25 we get, and here what we get? 24.5 we get. Now, once the variable is initialized with appropriate data, now the question is how the data can be accessed and how the data can be manipulated. Now, look here. Let us see first, if you want to manipulate, first of all, we have to access the members of the structure. So, how to access the data stored in these memory locations? Now, the members of a structure variable are separate entities. They are all separate entities. So, all these entities cannot be accessed using a single name. So, they are separate entities and hence they should be processed individually. All these data members must be processed individually. Another point is a member of a structure can be accessed by specifying a variable name. Now, here what is the variable we have here? The variable A here. We can access all these members using the variable A. So, here I write A. Immediately after writing A here, the specifying the variable has to be followed by what? A period. Period is also called dot. So, here after writing the variable A, we write what? Dot here. Can you observe the dot here? Immediately after variable A, you have to write dot. After writing dot, suppose I want to access the name field. In the name, what string we have here? RAM is there. I want to access this string. So, that string can be accessed using the variable name here. So, here I write A dot name, which in turn followed by what? Which in turn followed by the member name. So, here A dot, first you have to write variable, it has to be followed by dot, and then it has to be followed by the member name. What is the member name I want to access here? Name. So, here I write name. Now, tell me, when I say A dot name, this is A, this A dot name. What is there in A dot name here? RAM is there. I want to display the string RAM onto the screen. So, for that what we do here? We write printf %s. What is this percentage stands for? It is a format specifier for displaying a string. So, here when I say A dot name, tell me what is the output I get here? RAM. Next, now tell me to access marks, what should I do? First I have to write A followed by what? Dot followed by marks. So, here I write A the syntax, if you observe the general syntax, the syntax is something like this. Here first we write variable, then write dot followed by the member name. So what is the variable here? A. It has to be followed by dot, then followed by what? Marks here. Now here I write A followed by what here? Dot. That dot has to be followed by marks. Now tell me, what is A dot marks in our case? In our case it is 0025, and that has to be displayed onto the screen. For that, which function we have to use? A printf. So I write here printf %d. Now tell me, what is the output we get? Output will be 25. Similarly, to display average, what is average? 24.5. And to display this average, first of all, we have to access this data. How to access this data? Using the variable A and using the data member average. So here I write A dot what? Average. If I say A dot average, I have to display. For display the average, what is the statement to be used here? Printf. So here the output will be 24.5. I hope now we know how to access the members of a structure and how to display the members of a structure also. Now we will go to the next section. Now let us see how to write a program to simulate the multiplication of two fractions. Now let me take the fraction value. One is 3 divided by 8. It is a fraction. This 3 represent the numerator and 8 represent what? The denominator. So here I can access this because it is a numerator. I use one variable by name n. It is an integer value, so I say n is of type what? Integer. What is the next one we have here? 8. 8 is in the denominator. So I write d here, and d is of type what? Integer. So any fraction contains one numerator and another denominator. Both are of type what? Integer. So I enclose these two declarations inside the brace, and here I write type def followed by which keyword? Struct. So I write type def struct, and every fraction consists of numerator and the denominator. So here I write fraction. Now I want to multiply two fractions. So I write 3 by 8 into 4 divided by 7. Now tell me, what is the result? Result will be, first we multiply the numerator. 3 into 4. 3 into 4, how much? 12. So here I write 12. 8 into 7, how much? 56. So if you multiply these two fractions, the result will be a fraction number only. Okay, now how many fractions are there now here? 3 fractions. This is the first fraction, second fraction and third fraction. So to store 3 fractions, we require how many variables now? 3 variables. So here I write a comma b comma c. All are of type what? Fraction. Each fraction has how many fields? 2 fields. One is numerator as well as denominator. So here memory will be allocated for 3 variables. Now here I go and allocate the memory for the first variable. It has how many fields? 2 fields. One is the numerator and another is the denominator, and these two memory locations have a common name. What is a common name? A here. Here we have another variable b. So for this variable b also memory will be allocated containing the numerator and denominator. This n is of type what? Integer. D is also of type what? Integer. These two memory locations can be accessed using the common name b. There is one more variable c here. C is of type what? Fraction. Because it is a fraction, memory has to be allocated for numerator as well as denominator. So here I allocate the memory for the numerator, then I allocate the memory for the denominator. Both the memory locations can be identified by the common name. What is the common name here? C. So here I write the common name C. These two memory locations can be accessed by the name C here. Next, now in this memory, in a.n, in this field, I have to copy 3 divided by 8. Three divided by 8. I'm sorry, cursor is not working. Stop ಮಾಡಿದರೆ cursor ಯಾಕೆ work. ಇದು ಕ್ಲೋಸ್ ಮಾಡಬೇಕಾ? ಕರ್ಸರ್ ಇದಕ್ಕೆ ಮೂಸೋಕ್ಕಾಗ್ತಾ ಇಲ್ಲ ಇದು. Now let us see how to write a program. Now here I have 3 divided by 8. 3 divided by 8 and 3 represents the numerator which is of type integer, and here we have 8. 8 is also, it's a denominator which is of type what? Integer, so I write integer. And here we enclose these two data members inside the braces, and here I write a fraction. Here I am going to write a fraction. I have to multiply that with 4 divided by 7, which is equal to how much? 12 divided by 56. So here 3 into 4, 3 into 4 how much? 12. 8 into 7 is how much? 56. Now can you tell me how many fractions are there? 3 fractions are there. So here we require how many variables? 3 variables. So I write a comma b comma c are of type what? Fraction. Here we have ABC. ABC is of type of fraction. Now memory will be allocated for A, consisting of how many fields? 2 fields. One is numerator and another denominator. And the entire block is identified by the name A. Next, memory is allocated for the variable b. Here I write the variable b. There is one more variable c here. Memory will be allocated for the variable c also. Now I want to store 3 divided by 8 in this field. That is a dot n and a dot d should contain 3 divided by 8. We have to read the data into these memory locations. So that can be done using scanf. So here I write ampersand a dot n and ampersand a dot d into these two memory locations. Into these two memory locations I have to copy the data from the keyboard. So I write what? Scanf. Now normally before scanf what we write? Printf here. So we display fraction 1 which is of the form x divided by y. Now suppose the next number I want to store in these two memory locations, that is 4 divided by 7. Now tell me how you read this data into the variable b. That can be done using ampersand b dot n and ampersand b dot d. Into these two locations I have to copy the data from the keyboard. So that can be done using which statement? Scanf. So normally before scanf we write printf. So I write printf enter fraction 2. Now what we should do? We have to access the numerator of the variable a, the numerator of variable b. 3 into 4 I have to multiply. 3 into 4. So how we access this 3? 3 can be accessed by writing A here. 3 can be accessed by writing A dot n. So here I write A dot n and B dot n. What should I do with this A dot n and B dot n? A dot n must be multiplied with B dot n and the result should be copied into which variable? C dot n. So 3 into 4. What is 3 into 4? 12. 12 should be copied into which location? C dot n. So into this location 12 should be copied. Next I have to multiply the denominator. This is the first denominator 8. What is the second denominator? 7. 8 into 7. So first of all we have to access 8. How you can access 8? A dot d. How you can access this is 7? You can write B dot d. Both have to be multiplied. So 7 into 8, how much? 56. That 56 should be copied into this memory location, that is C dot d. So now we get 56 here. Now finally we should display. We have to display C dot n. We have to display C dot n and C dot d. So here we write printf result equal to %d C dot n comma C dot d. Now we get the output 12 divided by 56 onto the screen. Now all these statements, whatever statements are there, all these statements must be enclosed within braces, and here I write void main. The declaration of printf and the declaration of scanf will be available in one header file. So go there at the top and write #include stdio.h. I hope we understood how to write a program to simulate multiplication of two fractions. Directly we cannot multiply two fractions, so using structures we store the fraction in two fractions in how many variables? A and B, and the result I am going to store in the variable C. Now we will see how to trace a program to simulate the multiplication of two fractions. Now we know that execution always starts from the function main. The moment control comes here, memory will be allocated for the variable A like this, and then memory will be allocated for the variable B something like this, and memory will be allocated for the variable C also something like this. The next statement to be executed is printf and scanf. So if I enter 3 divided by 8, that 3 will be copied into which field? A dot n. We get the message 3 divided by 8, and the 3 will be copied into A dot n. Next 8 will be copied into A dot d. Next, what is the next statement to be executed? This printf and scanf. If we execute these two statements, I will get the message enter fraction 2, which is of the form x divided by y. Now by looking at this, if you enter 4 divided by 7 something like this, that 4 will be copied into which field? B dot n, and then 7 will be copied into B dot d. Next statement to be executed is this, that is C dot n equal to A dot n into B dot n. Now tell me, what is the result if you multiply A dot n and B dot n? The 4 into 3. 4 into 3 is how much? 12. 12 will be copied into C dot n. So 4 and 3 are multiplied. The result will be copied into C dot n. What is the next statement to be executed? C dot d equal to A dot d into B dot d. Now if you multiply these two, we have to multiply 8 and 7. 8 into 7, how much? 56. 56 will be copied into which field? C dot d. Now when we execute this statement, we get the result onto the screen. Result equal to how much? 12 divided by 56. Now we know how to trace the program to multiply two fractions and how to trace the program to simulate multiplication of two fractions. Now we see what is the size of a structure. Now this is the tagged structure. Now tell me whether memory will be allocated or not allocated. Memory will not be allocated. If you want to allocate the memory, then you have to use a variable. Suppose I use a variable CSE. CSE is of type what? Student. Struct student. Now here what will happen? Memory will be allocated. A block of memory is allocated something like this. And this block is identified by the name CSE. And then memory will be allocated. the memory for each member of a structure is allocated in the order specified within the braces. So, first memory is allocated for name. Name takes how many bytes? Name takes 10 bytes. So, like this, totally name takes 10 bytes ranging from 0 to 9. Then marks takes how many bytes? 2 bytes, because marks is of type integer. And then we have average. The average takes 4 bytes, because average is of type float. But there is one more field called weight. Now tell me, what is the size of a double? If it is a 16-bit machine, then size of the double will be 8 bytes. So here for weight, for this weight, 8 bytes will be allocated. 1, 2, 3, 4, 5, 6, 7, 8. Now let us see. Suppose the address of the first member is say 2000. Address of the second member naturally will be 2010, because it is 2000 to 2009. So totally it is 10 memory locations. So 2010 is the address of the marks. What about the address of average? Address of average will be 2012. And then tell me, what is the address of weight? It is 2016. Okay, now let us see what is the size. Now if you observe the size of a block, the size of a block is the sum of individual sizes of the members. So how many members are there? 4 members are there: name, marks, average and weight. So here tell me, name takes how many bytes? 10 bytes. 2000 to 2009. So totally 10 bytes are there. And then 2010 and 2011, how many memory locations are there? 2 bytes are there. And then 2012, 13, 14 and 15. So totally how many bytes we have? 4 bytes. And then starting from 2016 till 2023, how many bytes are there? 8 bytes are there. Now if you add all these things, we will have totally 24 bytes. So if you observe, the address of any member is greater than address of previous member. Now tell me, what is the address of marks field? 2010. Definitely it is greater than address of name field. What is the address of name field? 2000. Address of average is greater than address of marks. Address of weight is greater than address of average. So the address of any member is greater than address of its previous member. Next, now let us see what is the concept of a slack bytes. Take this structure. Is memory allocated for this structure? Definitely not. Now the memory, if I want to allocate memory, this structure must be associated with the variable say CSE. CSE is of type what? Struct student. Now memory is allocated for name consisting of how many fields? 10 fields ranging from 0 to 9. And then we have marks 2 bytes, then average 4 bytes, and then weight takes how many bytes? 8 bytes. Now what will happen is, suppose I write 2000. What is 2000? 2000 is the address of the first memory location. Now look at the point here. In the structure definition, double is the largest data type with how many bytes? 8 bytes. Character takes only 1 byte, but because it's a name of 10, it takes 10 bytes. But if you take size of character, size of int, size of float, size of double, double takes how many bytes? 8 bytes. So in the structure definition, double is the largest data type with how many bytes? 8 bytes. So the starting address of each member should be divisible by 8. Address of each and every member should be divisible by 8. So here, what is address of the first member? 2000. Next address of the next member marks must be equal to 2016, because 2008 cannot be the marks of the name. 2008 is the address of which field? Name field. 2008 cannot be the address of marks field. 2016. Next, what is the next number which is divisible by 8? 2024. Next one is how much? 2032. So if you observe, address of every member is divisible by 8 only. Next, if you take 2010, 11, 12, 13, 14, 15 and so on, ranging from 10 to 15, 10 to 15, and here starting from 2016, 18 to 23, 18 to 23, and 24, 25, 20, 28 to 31, 28 to 31. Here these are all called slack bytes. These slack bytes are not used. These slack bytes are not used, but they waste the memory. Okay, now let us see what is the total size. We know that 24 bytes already will be taken by the name, marks and average. 16 bytes for what? The slack bytes. So together it will be 40 bytes of memory. So what are slack bytes? In some machines, the memory for the members of a structure is allocated at certain boundaries called word boundaries. 2000, 2016, 2024, 2032 and 2040, they are all word boundaries. See here, these are all word boundaries. Point number 2, in such cases, extra bytes are padded at the end of each member, whose size is less than the size of the largest data type. So here, if you observe, these are called what? Slack bytes. This is also slack bytes. So totally how many bytes are there here? 1, 2, 3, 4, 5, 6 slack bytes are there here. And here how many slack bytes are there? 4 slack bytes are there, and so on. So extra bytes are padded at the end of each member whose size is less than the size of the largest data type, so that the address of each member starts at a word boundary. And last point is, the extra bytes that are inserted at the end of each member are called slack bytes. The memory locations shown using a black color, they are all called what? Slack bytes. So these are slack bytes. The data cannot be stored. The memory is wasted using slack bytes, but only advantage is the data can be accessed very fast if the members are divisible by the word boundaries are there. If the data is stored at the word boundaries, the data can be accessed very fast. Now let us see what is advantage and disadvantage of slack bytes. The first one is, the extra bytes do not contain any valid information and they are useless, wasting the memory space. This is the disadvantage. In this situation, the size of the structure may be greater than the size of the individual members. Point number 3 is, the advantage is that the data accessing at word boundaries is very fast. The size of a structure may be equal to the size of the individual members also. In that case, if the size of the structure, if it is equal to the size of the individual members, then slack bytes are not used. So when slack bytes are not used, whenever the size of the structure, if it is same as the sum of sizes of the individual members, then slack bytes are not used. In that case, addresses will be 2000, 2010, 2012, 2016. Now we know how to write the program. Now let us see how to copy one structure to another structure. Now look at this structure here. We have name field is of type name field, marks and average. First field is of type character, second field is of type integer, third field is of type what? Float. Now we have the variables A and B. Memory will be allocated for variable A. The first 10 bytes are for what? Name. Second 2 bytes for marks. Next 4 bytes for average. Similarly, memory will be allocated for the B also. First 10 bytes for name, another 2 bytes for marks, another 4 bytes for what? Average. Next, now look here. Copying the data stored in one structure to other structure can be achieved using the assignment operator. I can write something like this. For example, I can write, I want to copy whatever is there in B to A. So we write what? A equal to B and it should end with a semicolon. Similarly, if I want to copy whatever is there in A to B, I can write B is equal to A. Now this is also okay here. So, you can write A equal to B, or you can write B is equal to A. In the first case, what will happen? The entire structure B will be copied into A. In the second case, the entire structure A will be copied into B. Now, look at this structure here. Memory will not be allocated. How many variables are there now? Clearly see how many variables are there? 2 variables are there. So, a block of memory for variable C, another block of memory for the variable D is allocated. Now, how to copy now? I can write C equal to D, absolutely no problem, that is okay. I can write D equal to C, this is also okay. But remember, you cannot write A equal to C something like this, because A is different structure and C is different structure, so you cannot write, it is an error. I cannot write A equal to D, it is also an error. I cannot write C equal to B, it is also an error. And similarly, I cannot write D equal to A. If you observe, the two structures are used and the members are same, type is same, but still you cannot copy. So, one structure variable can be assigned to another structure variable of the same data type. Even though the members of both structures are in number, are same in number and type, remember both structures are considered to be different. Now look here. Now the question is how to copy the data stored in one structure to another structure. This is possible by copying the individual members of the same type and size. For example, so if you want to copy structure C to structure A, if you want to copy structure C to structure A, we cannot write A equal to C. What we can do? It can be achieved by copying the individual members as shown below. Suppose the string RAM is copied into the name field, 25 is copied into marks field, and say 24.5 is copied into average fields. Now what will happen? How to access the name field? C.name. I want to copy into which field? A.name. Now the question is, can I write A.name equal to C.name? It is not possible because name is a string. So what we can do? We, instead of writing equal to here, you replace with a comma and we use which function? String copy function. Now we have string copy which copies the name from C to A. Now what will happen here? RAM will be copied into this field now. Next, I want to copy C.marks into A.marks. So we can write A.marks equal to C.marks. Now what will happen? 25 will be copied into this field. And finally, we have C.average, which is 24.5, that I want to copy into A.average. So that can be done using the assignment statement A.average equal to C.average. Now, can I write A is equal to C? No, it is not possible. I cannot write A equal to C. It is an error. So if you want to copy individual members, it is allowed. I think we stop at this point and we meet in the next class.